let's talk about relative velocity. Now for this one, let me give you a simple example. Because whenever you're in a train, okay, assume that another train passes next to you. Then, you get to see that either the train is going very fast or the train is going relatively slower. So that meaning of relative is very important. Okay, let's look at couple of examples. See this, we have look at these two trains. Okay, now say if these two trains are moving in the same direction. Okay, say you have train A and train B. Both of them moving in the same direction, correct? Then what you feel is that, one train is moving a little slower than the other one. Like in the sense, in this case, train B is moving a little slower than train. Okay, why that occurs? You will get to see that. But look at the next example. See this? Two people are there. One person is moving like this, and another person is moving in this way. And look at it, both of them are moving in the opposite direction. Correct? Here also we have relative velocity. Okay, now mathematically, how do we go about it? See, if two objects are moving in the same direction, look at this one, then you subtract the speeds. Okay? And if two objects are moving in the opposite direction, then you add the speeds. Okay, this is what we call as relative velocity. This is the reason if two objects are moving in the same direction, then you feel that one object is moving slower. This is all about relative speeds. Okay. Now this you guys can relate. If two people are like two friends are cycling next to each other, then they can around talk and they can go right. The reason is what? The relative velocity between these two people is very less. So around they can talk and they can. But if two people are moving in the opposite direction, then the relative velocity is quite high. Okay. Now with an example, I think you guys will understand it even better. Okay, let's look at an example. Okay, look at this one. Ashok and Balu are going for a picnic. Okay. Now, guys, the story is not important. Look at the values, what is important. Ashok is traveling at 30, Balu is traveling at 50. And that too, they're moving in the opposite direction. Correct? And the distance between both of them is 200 kilometers. The question is what? At what time they're going to meet for the picnic? Okay, now let me emphasize on what is important here. Speeds are important. Ashok is moving at 30, Balu is moving at 50. And another important parameter is the distance, which is the distance between them, which is 200. The most important parameter is the direction. Both of them are moving in the opposite direction. So they are going to meet at a particular point. If they are moving in the opposite direction, recall, you're going to add the speeds, correct? You're not going to subtract. So let's try to solve this and let's try to figure out how we can go about. See, A and B, the distance is 200. Now, A is at 30 km per hour, B is at 50 km per hour, correct? So, what time are they meeting for the picnic? Basically, this is the question, isn't it? Now, let's try to solve this one. Very simple. You have A and B distance is 200. A is moving at 30, B is moving at 50. So, what is the relative speed between them? 50 plus 30 or 30 plus 50, which is going to be 80. Correct? So, A moves this way, B moves this way. You have a point P, let's say P. P is the point, the picnic point where both of them are meeting. Okay. What is the distance traveled by Ashok, which is AP? And BP becomes the other person's distance, correct? So you have two distances. One person is AP, another person is BP. When you add AP and BP, what is the total distance? AP plus BP? That's going to be 200, right? The total distance. So what will be the time? Total distance by the speed. 200 divided by 80, which gives you 2.5. That means they are going to meet after 2.5 hours. And you know that they're going to start at 8 a.m., 8 in the morning. That means both of them are going to meet at point P at 10:30 a.m. See how easily you guys can solve with the help of relative velocity or relative speeds. You know the distance, you know the time. Just calculate what is the relative speed, then you know the distance, and you're just going to add both of them, the relative speed, then calculate what is the time taken. So 200 by 80, here it's going to give you 200. The same type of things you can also do if two objects are moving in the same direction. Okay, like after how many hours they are going to meet, or what is the distance which they are going to calculate, these kind of things. Okay, this is an example as to show you how relative velocity can be used in solving simple and easy problems.